That's the energy I want. Okay, so we have been across like a lot of things. We learned about multi-cloud architecture, how to achieve that, best practices of industry. Was that interesting enough? Nice. Okay, so I think I have got a good audience, and my talk would be like adding some more value to that. Before starting it, how many of you have deployed your applications on cloud? Pretty much everyone, and rest of you are going to do that soon. Okay, so we are, and how many of you have implemented continuous deployment for your applications? Pretty much a lot again. Nice. So this is a little bit of my title and the organization where I work for. I work at Evo's Microsystems, which is a company that handles and that works with video streaming. So we do design the tool by which big organizations like Disney, Warner Brothers, Discovery, HBO, they do stream their channels through. And earlier they used to have those big routers and like all those data centers set up at their office, but now we have moved on to cloud. And we are also using multi-cloud, so I was like really interested at Abhinav's talk. So we are going to we all of us have some or other time experienced something like our servers being down, right? So if a server goes down, this is what per minute it costs. So isn't it a huge amount per minute? So we should what can we consider to have lesser of a few downtime? Anyone? So
Scalability, auto scale.
yeah, auto scaling, or you can even say we can switch on to some deployment patterns which offers zero downtime, or even if system goes down, there's something to fall back. So that is what I'm gonna talk about. Yeah. So in the very first slide, it was written in blue-green that we are going to talk a bit more about blue-green, but there are other deployment patterns too. But what's the advantage of opting to these deployment patterns? They most of the deployment patterns have nowadays, we need to be very peculiar about which deployment pattern we are choosing, and we should incline to zero downtime because of course we saw the number per minute, the cost is too high, so everyone wants to save on their money. Seamless rollback, that means we are going to have something like whenever the app goes down, instantly we have some other server to fall back. And environment separation means we have different environments to test, and every user of our product may have different needs. So depending on that, we need to have environment separation as well. So let's see what are the different deployment strategies available. Because if we know about only single deployment strategies, we won't be able to decide which is the best for us, right? So one might be sufficient enough. If we have a say small testing application, we might just go to traditional recreate deployment pattern. What it does, basically we do have our load balancer, and then we do have our applications deployed. But when we deploy a new version, what happens is, while the new deployment is going in place, application goes down for some time. And then it's the new, basically load balancers point to the new deployed servers. So this is the recreate pattern. But then the time in between which we see during update time, that during which our system is down. This time is dependent upon how much time your application is taking to spin up. And sometimes it might be a minute, and sometimes it goes more than 5, 6, 10 minutes. And we don't want, in these fast technology growing phase, we don't want our app to be, or our services to be down for this much time. Next is rolling update. Oh, there's some cut off. Okay. The next is rolling update deployment pattern. What does this mean? It means that our applications or our service has been separated into different, you can say, services, and one at a time services are being deployed. What it means is we had like old service. It is if the new one or the new alternative of it has been deployed, then it just switches over to that. So our like during update, our application is nothing but having like some parts of the previous version and some parts or some services of the new one. What does this offer? This also offers like this also offers something like very uh, quick rollback, and it also does not like have that downtime for our application. But then, do we have something like zero downtime and quick like another server on which we can roll back? Because we are rolling up one by one, so the services which we are removing, there's no like preserved state for rolling back. Every previous stage is basically our services and plus new deployment services like are clubbed together. So there's this blue-green deployment. So what does this offer? This is the colors are not that visible, but then like that's blue color and that's green color. Just tell your eyes to see that way. Okay, so we do have a load balancer again, and our services running beneath them. Our old pattern is our old deployed services, which is say designed or said as blue, and there's another service or another box of service on which we are like just installing or updating all our services called green box. And what happens is when you are having your previous version at that point of time, we are having all the services running. In the new version, we are going one by one deploying the services, and as soon as the new version is ready or the blue side of it is running and the green side of it is ready, we just switch. So in that way, what do we have? We have our previous version of application going on, right? So what does this offer? Of course, the first thing which we saw over there, zero downtime, seamless update or seamless rollback again, as well as you can say something to rely on when everything goes down. So when the new version is not working or having something, we already have the old version stored. Now this comes up with some, you can say, slight drawback, as you need to your old services or old servers are not running exactly, but then old servers are still there. So it might add to the operational cost, but then we need to be very peculiar if we want zero downtime, as well as if we want to always have something to roll back, then we should keep those old services like the first blue box. And in the next update again, since green one is the currently running one, the blue one comes to be next, and it goes, the cycle goes on like this. We have one side of server running for having all our services deployed, and next time when the service is running is the next color, like the next stack. And then once it's done, it just switches again. If like blue green, it goes like that, and depending upon if something goes wrong in the green side, it just keeps on to that, and your services don't seem to be down. No, neither any of the buggy code, like in rollback updates, something like this might happen that say you have 3 endpoints to your service, and at that point of time, what happened is first 2 part went successful, third one did not. So what you have is 1 part of the old service deployed and 2 of the new version of your service. At this point of time, rolling back would become a little bit difficult. So that is why people, those who want to have seamless update for their entire set of services, you can go for blue green. Now, so is it really important to have automatically and like instantly rolling back? We can see some example of it. What happened was Microsoft was updating their services. Meanwhile, this went down. And how we were feeling? Because like most of our companies do use sometimes Teams. So if any of the services goes down, this is what happens. And you might see that no one is ready to accept their mistake. So we all make mistake. If it is a beginner, they just step on and deploy the service right away. Like they do write deployment scripts as well, but then something like the deployment script, if that doesn't work, they just end up hitting themselves. But if we are experts, we do mess around with things a lot. Yes. But then at the end, if like services might go wrong, these are all computers, not humans, and humans make mistakes too. So we go around and see how a blue-green service or how a deployment strategy can be deployed. So we heard about Kubernetes and it is quite platform agnostic. We can use it on any cloud service provider, right? So what we can do is we always go through and create an image. An image means a Docker image I'm talking about. A Docker image is like something that has your application, all the dependencies, as well as like basically an environment in which your application can run. So you create a cluster and then what we do, we put that, we cannot like keep the Docker image after creating it on our machines because you want that to be available, say on different cloud providers, or you want it to be used from different environments as well. So that is why we store that image over some container registry. This container registry can be of your own server on some like different, on the Docker itself, or you can use even Google Container Registry. Why I have showcased the Google Container Registry here? Of course. So in Google Container Registry, you can create your own private container registry where all your Docker images are there. And while that happens, that image can be referenced or pulled onto your local machines as well as other cloud providers or other services and even Google Cloud, GCP or G Cloud Console or anywhere you want. So this was the building and putting the image or putting your run ready script over something or run ready application over something. Now you need to have something to run it, right? So we have Google Kubernetes engine to run our, basically what Kubernetes is, if I go in a brief, you might, like many of you might have aware, but for those who are not, it is a master-slave architecture-based system where we have multiple pods or multiple nodes running our application and one managing it all. How? The management thing goes beyond your network, internal networking, load balancing, and even like if something in between the running underlying nodes, you can say the pods goes wrong, Kubernetes engine itself like recognizes and fixes that. So you need not to worry about the underlying servers if you use GKE. Yes. So container registry we saw already. Next is we have a small demonstration going on. So how many of you go and do things on CLI or go and do things on like from your shell? I love doing that because it makes me feel something like a hacker wala feeling. Because no one else, like a non-techie can never understand what's going on in that black screen. and what is she doing? So that is why I love doing that. So you can have a cloud SDK. Using that, you can basically run your Kubernetes engine and run your application on. So this is another tool which we'll be using, and I'll be showcasing this after we are done discussing. So let's quickly switch onto my laptop. My GCP console opened up over here. I have a small GitHub repository that does have this code. Later at the end, I will share this as well. Let me quickly open that repository as well. Meanwhile, what I am doing here, or what I'm trying to do here, is basically clone my repository and get into this small. I have built a small, you can say Java Spring Boot application. What it does is basically it has my application going to be deployed in blue and green two ways. I have two different versions of the app itself written over here, the current and new, and then I do have all the scripts which I have used to deploy as well. We don't want to go and do things on the cloud writing by hand. So we better use scripting so that like in future, if you want to change the platform for deployment, it's easier to do with the YAML file or the configuration as code file, you can see. So what happens is I do go over my GitHub repo, and if I see here, I have my repo already cloned. It's, let me just clear it and then show you. Yep. So we have our repository already installed. If we do,
is this visible to everyone, or do we need to zoom?
It's fine.
clear enough?
Okay.
So let me show this. Like I have all the commands written over here as well. So you can see that all the Google Cloud commands, or even like getting into spinning up the Kubernetes engine, I have it written over here. So anyone wants to have a look can go star or clone the repository and give it a try yourself. Now, what we do here is we create Docker images for our old as well as new version of the application. And as we discussed, like the very third slide of me talking about the application itself was basically generating the containers, then creating basically or putting it over to container registry, and then moving on running it on Kubernetes or GKE. So we can see here. If we spin up the old version of our app, let me do that. Current, yep. Okay, so I do have already current version of the app going on. The current version of my app is already running with this container ID, and it is on port 8080 of TCP of my this machine. Now, if I go ahead and do apply on my kubectl with deployment old.yaml where we have the script. I think I have not started using it. Anyways, let me quickly go back over here and show you what I have over here. So as soon as I go ahead and do this old apply, what it does is, and what let's see what it has already. So what it has here is basically just spinning up the app 01 version, and it is taking the image from our container registry, which is my project ID and the current version of it. The same Docker image which we saw was running on, and it is on port 8080. Next up, like as soon as we change it to new, what happens? What change we can see? We can see that the name, like the image which we are seeing to have the container running within Kubernetes is new one. And how are we gonna switch? We are going to switch the traffic between the two using this command. So as soon as we do apply the new service, what happens is all the traffic which was going to port 8080, which had app 01 or app old, will be changed to app 02. And of course, at the end I have written this because it costs and it takes huge money if we like leave the clusters and leave everything running. Okay, so we don't want to do that. Per minute downtime is a cost $7,000, but per minute uptime also costs us money. So let me switch back to the slide. And I'll go to the one where we were. We were over here, where we were seeing the demo. Now, so what else can be there other than just seeing our app is running or not? What else GKE provides us? We already discussed about recreate, which was like old version is running in between while updating, the system goes down and then updated version. We already saw even the rolling updates in which some part of it has been rolled out, but like some of us might think that we want to go with roll up, but not exactly for all our users, because if something goes down, like what's the response and how the system behaves when entire traffic is redirected to the new site. We don't want to like do that all at once. In that case, like if our requirement is like that, we go to something like canary deployment. What's canary deployment? Same as roll up update, rolling up update. But what happens in there is we deploy some part of it and then we don't redirect the entire traffic. Rather, we just like restrict our traffic, incoming traffic, to the new version of the application. So that's rolling up with some testing and you can say limited production traffic. And then like for those who intend to go for just testing part of it, like just want to test how their new version behaves, or just want to like visualize what happens or jot some data down, they can go for shadow deployment. What it happens is, while having the old system, you can have a new system, like new deployed system, and it is just the shadow. It is not exactly any new traffic coming. Whatever traffic is coming to your old system in real time or old services in real time, users are getting the data off from that server only. Meanwhile, the same request is forwarded to the new system, and you are able to see or monitor, or you can even say observe what happens to your new system, and then you can, like, of course, go for any other deployment to deploy it in a regular environment. So for our application status, like, we do go for monitoring, and all these things are inbuilt and in-house with comes with GKE. That is why I wanted to like throw some more light on this cloud logging. So cloud logging comes within GKE. How do we use that? Of course, when our systems are deployed and up, we don't want that to just be there. We want something out of it. And like, if anything goes down, we want to see the exact region, right? So tracing the system and like how the system behaves when user comes in, we want that to be known, right? So how do we log? Do we do this? Printf, this is working. No, right? There are 4 levels of logging basically that goes on, like warning, info, error, and debug. So error, like all these info you can see in action in the like dashboard like this. The red ones are error, the yellow ones are warnings, and debug and info are basically like the normal lines which you have written and which you like get, which developers actually has to notice if the system works fine. Now, error reporting also comes within GKE, and this is how the dashboard looks. So, overall help, how after, like, everyone talks about the continuous deployment scripts or the YAML file which we talked about, but after that's done, we can go through the SDK tool to like log the cloud monitor. Even we can visualize it, or we can use some other like third-party observability tool like Honeycomb or any other tool. And what that does is that takes the logs from your actually running system and visualizes that. That becomes, and even creates triggers, and basically you can have something publishing to the person concerned or the team concerned, so that you are first one to take action while the app is rolling back and it has already been to a stable version like the previous version or something like that. Meanwhile, to be aware of something has happened, we do go through and use these features of GK. Now, the last part is that we have been through logging, we have been through monitoring, we have been through basically testing strategies. Main part was basically while monitoring the applications, entire applications, how we are redirecting or how we are taking information from that. Because we might sleep, we might have an off time, but the application never does. People from across the globe visualizes or uses that. So we need to be very peculiar and particular about choosing the deployment strategies we are going on. And of course, depending upon the use of the application, we can see what deployment patterns we are selecting. Like your application might not need a blue-green and just suffice well enough with a rolling update. And of course, like everything comes with the pros and cons. So we need to be very particular about the cost overhead which comes with blue-green, and I wanted to mention that as well. So that was all from my side. Any questions? We just have 1 minute.
Thank you, Jyoti. And please give her a huge round of applause. Anyone have questions? So we will take just one question here, and Jyoti is here with us.
Last slide, I have resources. So, if not, the questions are coming my way right now. I have, you can find me over the internet using this QR, and you can find all the like link to the repository as well as whatever I did, like all the presentation and everything using that QR. So that's all. Thank you.